Greetings from the United States of America. Let me first thank Professor Muhammad Mohsin and all his associates who have been carrying out this conference on an annual basis on sustainable textiles, very pertinent topic. And I'm indeed very thankful again and thrilled to present my brief lecture as an invited keynote on sustainable technical textiles. So, technical textiles is very important these days. Technical textiles basically saved the world, and it's still saving the world as a supplement to vaccination. So, while technical textiles are saving the world, majority of technical textiles are still made out of synthetic materials. So, textile, fibrous materials and chemical engineering people have a lot of work to do to see the possibility of making these technical textiles using sustainable products, sustainable methods and sustainable finishing methods. So that's the reason we are gathered here to see the possibility of developing next generation technical textiles using sustainable materials. So we are proposing a model how to do that. I always go by giving example of a 3-leg stool or a 4-leg table. So we'll take 4-leg table as a pyramid here, and then we are going to analyze this presentation using 4S, number 4 followed by the letter S as in sugar, to do this. So in order to develop the next generation technical textiles, we need to have 4 yes. First, we need to sense, similar to developing any protective textile product, we need to sense. Then we need to shape. What is the situation here? Technical textiles are important. That is given. Then when technical textiles are important, what is the market space? What is the research and market phase for technical textiles? And the third one is how to keep developing and how to make it further better. That is nothing but an analogy towards protection. And then once you have developed a product, how to keep it safe. That is nothing but decontamination. So this 4S model has been used as a case in point for developing a particular technical textile known as decontamination wipe. Okay, and then technical textiles, particularly in the field of advanced textiles, in the field of protective textiles, need to be soft. They can be soft or they can be hard or in between. We are going to take, for example, here soft components. So what are first, let's go through what are technical textiles. Technical textiles are basically value-added textiles. They can be just simply a fiber, they can be a yarn, and they can be a fabric. So technical textiles are simply, they are basically anything that is value added to a fibrous material whose function is not just simply focused on aesthetics, rather it is focused on giving certain functionality, certain special characteristics. So technical textiles can be fibers, technical textiles can be yarn, technical textile can be woven, and a combination therefore. So it gives us an opportunity. Okay, you don't have to spend too much money putting infrastructure. You can even use a fiber as long as you give some value added functionality to it. Okay, what is the perfect technical textile for protection? I told you we'll take in this presentation example of protective textile. So this is the perfect protective textile example. You basically convert a human being into a zombie. It's protect everywhere, hooded structure. So this is the holy grail. The ultimate gold standard for giving you protection is airtight sealing. But if you give airtight sealing, this is the typical US Army uniform for chemical and biological defense, particularly chemical defense known as Joint Service Lightweight Integrated Suit Technology, JSLIST. So this is the ultimate panacea, gold standard as of now. But then the problem comes is, okay, it does protection, but at the expense of comfort. So people, when they are wearing this, are not comfortable. So if you are talking about comfort, natural fibers come into play. What did I say? Technical textiles are very good in providing functionality, but there are minute drawbacks, and one such drawback for ensembles like this is comfort. So sustainability can play a role, and if you are using a technical textile, predominantly they are coated. If they are coated, they are going to close the air pores in the fabric. When they are closing the air pores, what is going to happen? Breathability will suffer. So sustainable engineers, sustainable textile technologists, I mean, though not just simply living textile technology. Of course, those who are interested and those who work on sustainability have a lot of work to do, and that's also is security for us. So it keeps us working, keeps us researching, like Professor Mohammed Moshein and others. Okay, so if you look at technical textiles, predominantly, what did I say? Predominantly in terms of cleaning, in terms of wiping application, predominantly they are synthetic based, and predominantly they are non-wovens. And if you look at the face masks these days, face masks are predominantly made out of polypropylene, and face masks are predominantly made out of non-wovens. Okay, can we change this? That is what I'm going to show. Over the period of 3 years, since the summer of 2020, roughly 2.5 years, we have been focusing on bringing sustainable fibers in protective applications, particularly in the case of face masks. Can a sustainable cotton cloth alone be sufficient? Surely it may not be sufficient on its own, but it can provide additional layers, thereby not compromising the comfort. So we are trying to bring sustainable fibers into filtration applications. We are trying to bring sustainable fibers into cleaning or wiping or decontamination applications. Okay, so far this market space is predominantly dominated by polypropylene based synthetic melt-blown fibers. Now we all know what are non-wovens. Why non-wovens are finding application? Because they are reducing the number of processing steps. When you are reducing the number of processing steps, of course the cost of product comes down. So cost effective. And why we are using polypropylene? Polypropylene is cheap, right? For lack of better term, they are cost effective, but we are trying to give the positive spin towards using natural fibers. One, because they are biodegradable, and then they are comfortable, and it's very important for sustainability and saving God's green earth. Okay, so this is early definition. One of my students, who is actually from Bangladesh, Rubait Mahmood. My laboratory in the United States is really a United Nations per se. People from India, United States, Nigeria, Bangladesh, and so on and so forth come and do research. Thereby, we also get to know different culture. We get to exchange ideas. So it's really a mini United Nations. Most of laboratories in the West are like that. That's good. So this gentleman came from, as a young man, he came from Dhaka. And then he's now flourishing. He went on to work for Intel. Now he's running his own company. That's good. So non-wovens, why non-wovens? Easy to make, cost effective, and there are only 4 or 5 technologies at the commercial scale, at the manufacturing scale available. So you have to mix and match them. So predominantly these are flat structures. At the same time, they are drapable and bendable. So it can take the shape and contours of human body. So if anybody is interested in this paper, you may refer to this Man-Made Textiles in India, September 2000. Some 20 years back, we formed a simple definition for non-wovens, which is still used. Okay. Then I'm going to give you an example of non-woven products and say how important the concept of sustainability is, because predominantly the non-wovens we see are predominantly made out of synthetics. So we need to change. I think conferences like this, what it's held in Pakistan, will create more awareness to the advanced textiles, to the technical textile sector, to think about new applications, particularly using synthetic fibers. So these are typical examples of non-woven materials we see on a daily basis, and this is a typical moistened wipe. Predominantly it is polyester based. They also have some amount of viscose in it. We need to get cotton into this, okay? And then this is a typical Spunbond-Meltblown-Spunbond, 100% synthetic. Is there a chance to infuse some sustainable materials, rayon, cotton? That's all the task we have to do, all the way trying to balance the cost, functionality, and comfort aspect. So what are these examples give you an idea that this space is totally crowded with synthetics. So there is a chance for people working in sustainability aspects to bring in new ideas to see if the market would accept those ideas. So I'm going to give you two examples, one a face mask example, another an oil absorbent example to show this. Okay. So why face masks are important? We all know even now face masks are playing an important role because these viruses can mutate, they can change their background in a simple layman term. When they are changing the background, one particular vaccination may not be helpful, but vaccinations are lifesavers, no doubt about it. But face masks and other protection mechanisms like hand hygiene and distancing all enable, they cannot on themselves be a perfect solution, but they can help vaccination. So I'm not denying that. But when we started, before we knew the genetic code, genetic makeup of this particular virus, and the world was able to manufacture these vaccines at a large scale, face mask played an important role. But during February and March of 2020, face mask was predominantly manufactured in China, and if any supply chain crunch comes like now what we are facing, okay, the whole world is in a standstill. So everybody started coming with different types of face masks. There, the importance of cotton spotlighted. Maybe an adverse situation brought the importance of cotton and how cotton-based materials can be a lifesaver. So we all know what face masks are. I will quickly do a rundown on them. Prior to COVID, there are only two masks people predominantly knew. One type of mask which is very regulated and only in hospitals during surgery, where aerosol particles are generated during intubation. You put that intubating tube into your throat or nose. When the bodily fluid splashes as aerosols, then only even doctors and medical practitioners used this N95, which is nothing but FFR, filtering phase space respirators. Okay, and they are technically called N95. And then the ordinary synthetic fiber based 3-layer surgical mask. Surgical masks are again non-medical grade, medical grade, we don't want to go. But these are all predominantly synthetic based. When the shortage of face mask issue came, people were coming up with all sorts of, they are doing that in their kitchen tables, they were doing it in the garages. All sorts of materials like bandanas, ordinary cloth like this, people were trying to use. But they themselves may not be a panacea, may not be a solution. So these were used on top of the disposable or single-use face mask. So face covering, a new terminology came into being used, is known as face covering. So the major categorization of face masks were only N95s or KN95, whatever it is. These are FFRs, filtering phase space respirators. Then came the regular surgical mask. Then the third category came called face coverings. But then face coverings were not perfectly efficient in countering these minute, small particles. So we came up with a new concept called Pfizer. You take a synthetic face mask, that is surgical mask, and then on top of it add a single layer of cotton covering. Since cotton is comfortable to the human body, the conference is on sustainability, that is what I'm saying. You may not be able to use 100% sustainable material, but at least if you are progressing in the right direction to infuse sustainability into a technical textile, that's a step in the right direction, although we have a long way to go. Okay, so what we did, these synthetic fibers are very good in repelling the bodily fluids, aerosol particles, but they are not comfortable. So keep a thin layer, cotton layer next to your human body, and then on top of it put a surgical layer. And this combination, you see I'm talking on taking the sustainability step by step, this combination which has some amount of sustainability product into it, aspect of sustainability into it by infusing some sustainable natural material into this, it brings comfort. At the same time, it also enhances the functionality, it improves the filtration efficiency. And that concept, that product or that concept is known as Pfizer. It's like visor in a car, it's Pfizer. So since it protects the face, it's called Pfizer. It has a synthetic face mask plus a face covering, that combinatorial approach, which gives the necessary filtration and comfort. And the fourth one is, the bottom of the rung is simple cloth covering, is known as face cover. Okay, so this is a typical Spunbond, which is 100% made up of Spunbond-Meltblown-Spunbonds, short message service, SMS. This SMS is predominantly polypropylene based. We are taking this, adding a cotton layer to it. So this is the center material for that SMS, which we all know. And this is a typical N95. And what is N95? It basically protects human being 95% efficient for 0.3 micron size. Okay. So this is 300 nanometer size particle. It will protect 95% of them from entering your nose and entering your crevices. So that is N95. This is the gold standard used very rarely prior to COVID. But when COVID was at the peak, when vaccination was not happening at the peak, all medical practitioners and even people who are vulnerable started using N95. That led to shortage because this was predominantly monopolized by a couple of companies. And the general surgical face masks were all predominantly imported to the West from China. Okay. Now this is the concept. So we came up with this concept. What did I say? You take a filtering material, a non-woven material, and then the outer one is cross cloth covering. So this is, I'm showing a face cover with a non-woven filter and a routine cotton fabric as a cover. You can insert it. And this concept is what we call it as a visor, which protects the human face. Okay, and so a lot of ideas evolved out of this. That's one example. My time is only very limited. They asked me to finish within 20 minutes, so I'm trying to run. So that's one example how you can develop sustainable technical textiles. Technical textiles are predominantly 75 to 80% still governed by synthetic industry, but there are opportunities. Thanks to COVID, many opportunities are evolved. Okay, that's one example. So personal protective equipment with some sustainable materials into them. I gave you an example of a visor, a cotton cloth plus a regular surgical mask. That combination is known as visor. Now we'll switch gears. So that example is towards human health and life saving. Now we are going to protect the environment using sustainable material. Another example is oil spill. You know, oil is imported in majorities of countries, particularly in Middle East. People import from Middle East. So these are all transported by tankers. So here and there, somewhere in some part of the world, these spills happen. The spills happen in paddy fields in Pakistan, wheat fields in Pakistan, paddy fields in India and elsewhere. So people are interested in getting something that can soak up the oil, and that industry is again dominated by synthetic fibers, melt-blown fibers. So we are trying to see, can we replace those synthetic fibers with natural materials like cotton? Yes, we proved. Why this is important? We now know that situation, the Gulf of Mexico spill is the world's largest spill. Roughly around 4.25 million barrels of oil has been spilled everywhere. That caused problems to human, problems to marine lives, and also a lot of economic distress and so on and so forth. But the industry so far is only concentrating on using synthetic material, synthetic melt-blown as an oil absorbent. But we were one of the few labs early on to show that you can use a natural material like cotton to soak up the oil, because synthetic fibers, particularly melt-blown materials, non-wovens, these are very fine fibers, roughly about 1 to 5 microns in size, very small melt-blown fibers. They can lead to secondary contamination. Even though they are able to soak up the oil perfectly, no doubt about it, what are you going to do with this plastic material? They are not going to degrade. So the problem comes there in applications like this. So this is a typical melt-blown web, right? You can see this melt-blown is not very strong. So the fibers will just easily be removed from the surface. Okay, so they may lead to some microplastic issue. Microplastic issue is a big issue because some people are even finding microplastics inside the fish and animals people are using. So they can lead to a lot of health problems. So we are trying to get out of the synthetic fibers, particularly melt-blown fibers, and use natural materials. So what is the reason? So we are using a natural cotton. These are all the things which commercially people are using. The synthetic pig material, rubber based, and then synthetic white, predominantly melt-blown polypropylene, 1 to 5 micron size. Whereas we are replacing that with cotton. Cotton in a natural form will repel water because of the wax content in it, and they can attract oil. We were the first one to show that crude oil can be soaked up by cotton, that too natural cotton, cotton with seed coats. Pakistan, India, United States, particularly West Texas where I am, we are all very big in cotton producing. It's cotton dependent countries in one way or other. US exports cotton, Pakistan imports, India and Pakistan are very good in spinning, and Bangladesh imports cotton yarns and things like that. So cotton is part of the mainstay in countries. So we are trying to find additional applications. So we are taking raw cotton and making sure that raw cotton can replace synthetic materials in soaking up the oil. This has become commercial as well. And this is a typical example of a thermal power generating plant where they keep transformers inside the cooling oil. So the oil is used to cool these transformers for generating heat. What happens if there is a spill and there is a spark? The whole power generation capacity will be in a blast. So the oils, the seeping oil is all stored in pits like this. So we are trying to show that cotton-based absorbents can be used to soak up oil, and we were very successful in demonstrating this. And again, another problem which we are facing is dye pollution. So far, the industry has been looking at a lot of avenues for sustainability. Of course, dye, it is no way that we can get out of dyes in textile industry. So we are trying to minimize the harmful effects of dyes. So we are coming up with natural fiber-based water-soluble materials like PVA, polyvinyl alcohol is water-soluble material. Can we functionalize polyvinyl alcohol to develop some kind of a dye-absorbent material? So this is again tackled. So one of the prominent dye is rhodamine B. So we have used some metal oxide infused polyvinyl alcohols and PVDF, titanium dioxide webs, and then shown that the metal oxides can catalyze the harmful moieties in very toxic dyes, and then they remove the toxicity. So I have given you 3 examples. One, how cotton cloth layer can be used on top of surgical mask to come up with sustainable products that gives comfort and enhances the filtration, that's known as Pfizer. Second one is cotton-based oil absorbent, protecting the environment and human health. And again, water-soluble nano-based materials with functional chemistries like PVF and PVDF and PVA-based titanium dioxides to cleave the toxic portions of dyes such as rhodamine B. So with that, I think I am up to the time. So my lab works on all these, and I also publish newsletters which talks about market information and also research information called TechSnips. If anybody is interested to get those, I do it as a service to the industry and to particularly students. It's called TechSnips. You can send an email to me and then I will subscribe it. More importantly, you don't have to pay anything for it. You can email it to me, s.ramkumar@ttu.edu, and you will be getting it. Hopefully in every month we publish 4 or 5 times, only one story at a time. It's a snippet, so researchers can benefit a lot, industry can benefit a lot. With that, I again thank Professor Moshin and the University of Engineering and Technology in Pakistan for doing this on an annual basis. It's a good work. Keep it up, and all the best, and let's pray for a safe world. And thank you. And I also have to acknowledge these people from US Army and the person who commercialized one of my wipe technology, Mr. Amit Kapoor, and all